Hello everyone, this is Manish from Skillableindia. In today's session, we are going to discuss about the basic concepts of dimensioning and tolerancing. Okay, so how many types of dimensions are there? How many types of tolerances we use into our engineering drawings? Okay, so so all the things we are going to discuss in this. Now that we have understood the concept of identifying the dimensional units, okay, whether it's a metric, millimeter based system or an inch based system in the previous session, we will try to understand different types of dimensions we have. We will try to understand all the types of dimensions we have and the tolerances. Okay, so whenever we have the dimension like this, in this, let's say I'm giving over here one dimension which is 60 mm. Okay, so like this, the numerical is expressed in millimeters. Okay, whenever I'm writing without a decimal and zero, it means it's a millimeter based system. So this drawing is millimeter based system. Okay, so this is 60 mm. Okay, so this is called the dimension. Okay, so this is called dimension. Like this, we have different types of dimensions on this drawing. Okay, so in this you can see 20 plus minus 0.1 mm, 60, 30 mm. All these are dimensions. Okay, so now one of the fundamental rule of GD&T says tells that any dimension could carry a tolerance. Should carry a tolerance. Okay, any dimension should carry a tolerance, because manufacturing a part exacted to this dimension 60 mm is very difficult. Okay, so what we have to do is we have to add a tolerance in this. Let's say I am adding in this like plus minus 0.1 mm. Okay, so this tells that the part can manufacture anywhere between 60.1 or 59.9 mm. Okay, so in between this, so this portion of the dimension 60 plus minus 0.1 in this 60 mm is called the dimension, and 0.1 plus minus 0.1 is the tolerance. Okay, so when the word of question is what it is tolerance, when the question comes what is tolerance, so sometimes when we ask this question to the people, they say plus minus 0.1 in this is a tolerance, or 0.1 is a tolerance. But if we go through with the definition of the tolerance, so what is tolerance? Okay, so the definition here by the definition of tolerance is the difference between tolerance is difference between upper limit and the lower limit. Okay, so this is known as the tolerance. So you can when we convert this is into the upper limit, so this 60.1 is upper limit and 59.9 is a lower limit. Okay, so if we have the difference between these two, so the difference between these two is 0.2 mm. Okay, so 0.2 mm is the tolerance we have. Okay, so this is very important to understand that how to calculate a tolerance into the engineering drawing. Okay, so next, whenever we give plus minus tolerances, okay, in this way, whenever we give plus minus tolerances like 60 plus minus 0.1, so this is the plus minus tolerance. Okay, we say plus minus tolerance. Okay, so this is one of the terminology which we use regularly. The plus minus tolerance, so this particular dimension 60 plus minus 0.1 known as the nominal size. So in this case, this dimension is called the nominal size. Okay, so now the question arises, what is nominal size? Usually nominal size is the size that is specified in the drawing, okay, which is derived by design. Okay, so this is called the nominal size. I will write down the nominal size. What is nominal size? Nominal size is the size usually that is specified in the drawing, which is derived by design. Okay. So this is called the nominal size. The next terminology what we have is to understand is called the basic dimensions. Okay. Now we are going to understand about the basic dimension. So now what is basic dimension? So we will understand about the basic dimension. Basically, if we understand with the help of definition, then it is known as any dimension which put inside the box is called the basic dimension. Okay. Like in this case, you can see this 30 mm dimension, which is put inside the box is called the basic dimension. Okay. It is the theoretical dimension. It is theoretical dimension. Theoretically exact dimension, I will say. Exact word is very important. Theoretically exact dimension used for specifying location, orientation, or a profile. Okay, so this is called the basic dimension. So in this case, the basic dimension you can see written is in like this 30 mm. So 30 mm in this is a basic dimension and is used to get the location of this hole. Okay, so location to this of this hole, we use this 30 mm as a basic dimension. For the exact dimension, we use this specifying the location of the hole. Okay, so the next terminology what we have here is limit dimension. Limit dimension. Okay, so in this now we understand that what is limit dimension. So we will give you I will give you an example of that of the limit dimension is here. Okay, if we are using 60 plus minus 0.1 mm, so if we use similar terminology in the limit dimension, so we have to write limit dimension like 60.1 and 59.9. Okay, so this is the upper limit I have already told you, and this is the lower limit. Okay, so this is how we have to specify onto the drawing with the limit dimension. Okay, so then this type of dimension style. So this type of dimension style is called is known as limit dimension. Okay, now we have something known as unilateral tolerances. Okay, so what are unilateral tolerances and how they are helpful for us? So we are going to find out unilateral tolerances. With this example, we are going to understand lot of terminologies in today's session. Okay, so what is unilateral tolerance? In the previous session also I have told you this unilateral tolerance. So here if we use 60, lower limit is 0 and the upper limit is plus 0.1 mm. Okay, so whenever the tolerance value deviation is is only towards the positive direction. Okay, so the deviation of the tolerance should always is only towards the positive direction. It is known as unilateral tolerance. Okay, so here the lower limit is 0 and the upper limit is plus 0.1 or 0.2 or whatever the tolerance we are taking, but it is only towards the positive, the deviation in the tolerance we can have in the manufacturing is only in the positive direction, not in the negative direction. Okay, because the other direction is 0 over here. Okay, now the other terminology what we use regularly is in this. Okay, so this is called the unilateral tolerance. So now we go back onto the drawing, onto this previous example. Okay, so 60 plus minus 0.1, you can see over here the dimension over here. Here the deviation is on the positive direction as well as on the negative direction. Okay, at the same time the it is on positive and positive direction it is 0.1 mm plus 0.1 mm and negative direction 0.1 mm. Okay, so in this particular example 60 plus minus 0.1, so this is the example of equal bilateral tolerance. Okay, so this is the example of equal, because it in positive direction it is 0.1 and in negative direction it is 0.1. So 60 plus minus 0.1 is the example of equal bilateral tolerance. Okay, so this is so finally there is one more type of tolerance which is called as reference. There is one more type of dimension which is called as a reference dimension. Okay, but before starting the reference dimension, first of all, one more tolerance is there. Let's say if I have given 60 over here and in minus direction 0.1 mm and plus direction 0.2 mm. Okay, so in this particular case, this is the example of unequal bilateral tolerance. Okay, so this is the example of unequal bilateral tolerance. Okay, so these are the examples of the unilateral tolerance, equal bilateral tolerance and unequal bilateral tolerance. Now there is one more terminology which is used frequently in the engineering drawings. Okay, where while studying 16 fundamental rules of GD&T, I have told you of this the reference dimension. Okay, at that time I have told you that I will tell you about the reference dimension. So what is basically this reference dimension is, I will with the help of this example I will let you know. Okay, finally there is one more dimension. I will explain this dimension of the reference dimension. So in this case, this is the example. Okay, so when you take this drawing, very first dimension that we will meeting, if we are manufacturing this part, let's say if we are manufacturing this part, so first of all what we understand in this part is, first of all first we will meeting for the manufacturing, we will see this 60 plus minus 0.1 mm. Okay, so let us say that the manufacturer maintained this dimension as 60.1. Okay, so the while manufacturing, a manufacturer maintained this dimension at 60.1 mm. Okay, so let's say that the manufacturer maintained it, let's say, sorry, not 61.1, let's say manufacturer maintained 59.9 mm in this case. Okay, because 60 plus minus 0.1 having tolerance, so whether it is produced 60.1 or 59.9. Okay, so the manufacturer maintained this dimension 59.9. So he is maintaining this dimension. For this he has maintained this dimension, this particular dimension from here to here. Let's say he maintained 20.1 and okay, then this dimension, this from is this point to this point, the manufacturer also maintained 20 plus 1. Okay, the dimension. So here here the dimension is, now if we add up both the dimension 20.1 plus 20.1, so it will come 40.2 mm. Okay, now the overall dimension of the part from this point to this point is 59.9. So okay, 40.2. So in this case, what we get over here is 19.7. Okay, but the lowest dimension what can we maintain in this from this point to this point we are after manufacturing. Okay, so as per the drawing that this dimension should not be less than 19.9. okay, so maximum this can have 19.9 in with the help of 20 plus minus 0.1, but after manufacturing in actual reality we are getting 19.7 mm. okay, so whenever we come with such problems in the manufacturing, what we do is then we have to identify the dimension which is non-functional dimension. Okay, so when we come such problems, so we have to find out that which dimension is a non-functional dimension. Okay, so let's say we have find it out that this last dimension is a non-functional dimension. Okay, so here what we will do now is, so after identifying the non-functional dimension, in this case I have identified that this dimension is a non-functional dimension. Give that in parenthesis. So now this dimension I will give into parenthesis. Okay, 20 parenthesis. So this is called the non-functional dimension or reference dimension. Non-functional dimension or reference dimension. Okay, so this is how we have to find out this dimension, and the usage of reference dimension should be minimal, because in studying about the 16 fundamental rules of GD&T, it is saying that we have to minimize the use of reference dimension onto our engineering drawings. So the reference dimension is which is used for only reference and nothing to do with the functionality of the part. So this is all about the dimensions and tolerances. In the next session, we are discussing the next topic. Thank you everyone.